Olá, boa tarde a todos e todas. É um prazer muito grande estar aqui hoje com vocês, principalmente com os nossos convidados do Educational Testing Service de Princeton, uma organização das mais especializadas em avaliação educacional do mundo. E eu começo agradecendo, em primeiro lugar, a Fundação Itaú que patrocina a pesquisa, e os nossos convidados estão aqui a convite exatamente dessa pesquisa sobre inteligência artificial generativa e avaliação educacional. A pesquisa tem por objetivo mapear algumas iniciativas no Brasil e no mundo que estão acontecendo, tanto no que se refere à avaliação em larga escala, como também avaliações formativas, né? E já fizemos assim um grande levantamento, verificamos algumas tendências internacionais e hoje nós fazemos esse workshop com o ETS, Educational Testing Service, e com os nossos convidados, que são o professor Luis Saldivia, consultor estratégico no ITS, Educational Testing Service, no Instituto de Pesquisa do ITS, é uma organização sediada em Princeton, líder em testes educacionais e avaliação dos Estados Unidos. O professor Saldivia é especializado no desenvolvimento de avaliações, incluindo o NAEP, Avaliação Nacional do Progresso Educacional nos Estados Unidos, e Saldivia liderou a equipe do ITS até 2022. Participa também um convidado também do ITS, o palestrante Matthew Johnson, Matt, atual diretor do Centro de Pesquisa em Psicometria Fundamental e Estatística na Divisão de Pesquisa e Desenvolvimento da Education do ITS, foi diretor e professor de Estatística e Educação no Teacher College da Columbia University. É um prazer e uma honra muito grande estar recebendo aqui todos vocês, e temos depois como nossos debatedores grandes especialistas em educação no Brasil, o professor Rubem Klein, consultor da Fundação Cisgran Rio, o professor Chico Soares, professor emérito da Universidade Federal de Minas Gerais, a professora Maria Inês Fini, tanto o professor Chico Soares como a professora Maria Inês Fini foram presidentes do INEP, como eu também fui presidente do INEP, que é a instituição responsável pela avaliação educacional aqui no Brasil. E temos também aqui conosco a minha parceira na coordenação dessa pesquisa, que é a professora titular de Economia da Fundação Getúlio Vargas, a professora Priscila Tavares. Eu quero também fazer uma saudação especial a todos da Fundação Itaú que nos apoiam, em nome da Carla Cristine, que é coordenadora do Observatório de Educação e Cultura da Fundação Itaú, que tem feito um esforço enorme no que se refere a inovações na área de tecnologia em educação e cultura, com uma carteira de projetos a mais abrangente aqui no Brasil hoje, nessa área de tecnologia em educação e cultura. Né? A professora Carla está aqui nos acompanhando, assim como toda a equipe da Fundação Itaú. E quero também agradecer toda a equipe da Cátedra Instituto Ayrton Senna, a Silvia, a Bárbara, assim como a equipe que nos apoia nessa pesquisa, além da minha parceira na coordenação da pesquisa, a professora Priscila, para quem eu passo agora a palavra. Eu só quero dizer duas coisinhas sobre a nossa pesquisa. A nossa pesquisa, ela teve início em março desse ano, o relatório final deverá ser concluído até novembro, até o final desse ano, e nós levantamos várias iniciativas, temos mais inovações na área de avaliação formativa do que de avaliação em larga escala, e o nosso grande interesse em ouvir dos nossos dois convidados do ITS é saber em que medida as inovações tecnológicas, especialmente a inteligência artificial generativa, está impactando os processos avaliativos do ITS, que é uma das maiores organizações em avaliação educacional do mundo, né? Gostaria também de saber em que medida nossos convidados têm introduzido a inteligência artificial generativa para desenvolvimento de banco de itens, para o desenvolvimento de novas metodologias de avaliação, e ao longo dessa fala nós teremos a oportunidade de ouvir, com certeza, o que tem mudado no NAEP, o NAEP, né, o National Assessment Education Testing dos Estados Unidos, que é uma avaliação em larga escala que influenciou enormemente o SAEB brasileiro, implantado a partir de 1995, com a introdução de técnicas, metodologias e conceitos semelhantes ao NAEP naquela ocasião. Agora, eu acho que muita coisa mudou no NAEP, no SAEB tivemos menos mudança do que tivemos no NAEP internacional. Mas eu passo, então, a palavra à minha parceira na coordenação do projeto, a professora Priscila Tavares Albuquerque. Com a palavra, Priscila.
Obrigada, Maria Helena. Vou brevemente dar as boas-vindas, né, aos convidados desse evento, né, desse webinar, que para nós é tão importante, não só para a nossa pesquisa, mas principalmente porque a gente tem a expectativa aqui de aprender com o ETS, né, o que eles têm trazido aí de inovação com o uso da IA para as avaliações em larga escala e para nos inspirar aqui em mudanças que nós eventualmente poderemos ter nas nossas avaliações em larga escala no Brasil, né? Esse é o grande objetivo da nossa pesquisa, é gerar, levantar, né, esses dados, essas informações e gerar esse aprendizado para melhorar as nossas avaliações aqui no âmbito nacional. Então, agradeço pela parceria, né, nessa pesquisa e agradeço muito a participação dos nossos convidados.
Então, eu passo a palavra agora para o professor Saldivia. Por favor, professor.
Can you hear me now? Yes. All right. And can you see my screen?
Yes.
Yes. Is the screen? I'm sharing my PowerPoint presentation. Can you see it?
Yes, we can.
Okay, thanks. All right. So, and well, thank you. First of all, Professor Marilena, Professor Priscilla, thank you for the invitation. We appreciate this discussion, and hopefully through this hour we'll be able to discuss as colleagues. So what are we doing at ETS in terms of the generative AI and all of the technology approaches? But before we get to the AI, which is what Dr. Matt will present, I will talk about what NAEP has been, the changes that NAEP has been through the last few years. And that will give you the context in a particular practical situation of how we are implementing, technology changes, and in particular, there is an interest in AI, but we will talk about that too. So give me 1 second here. So I'm gonna set up my computer. Okay, so let me start by, I think all of us are familiar with the NAEP, but let me just to say a few words about NAEP. It's the National Assessment of Educational Progress. Is sometimes referred as the Nation Report Card. Is the largest national representative and continuing assessment of what the students in the United States know and are able to do. It is developed by the National Center for Educational Statistics, which is located within the Department of Education under the Institute of Education Sciences itself. The policy of NAEP is set up by what they call the governing board, which is an independent bipartisan organization made of governors, states, school superintendents, teachers, researchers, and representatives of the general public. It is, since 1990, NAEP started to report at the state level, with allow for comparison across the state, across the different states. But it's not a state assessment. Here in the United States, states have their own assessment, which are designed to provide individual data on students' abilities and skills. But NAEP provides an opportunity to compare across different states in the United States how the students are performing in this aspirational framework, which is the defined assessment for NAEP. So one of the major changes that NAEP have been through was the transition from paper and pencil to digital. And I believe that Brazil have been interested in the transition itself. And I can tell you a little bit about how that transition, provided us with some real opportunities and some challenges itself. So for the transition, we had two major goals. The first goal was to maintain the trends, the meaningful trends reporting that we have. We have been reported since 1990, so we wanted to keep the trend going. So we wanted to make sure that the change introduced by the delivery platform or delivery system did not impact our opportunities to continue to report on trend. So there was a significant number of studies, in particular, how to, what we call transadapt the existing content from paper to digital, and to study what was the impact on the transition to the new delivery mode. On the other side, the other goal of the transition was to really leverage technology to improve content representation. So we wanted to make sure that how to use the computer affordances, new item types, new interaction with the computer, to make sure that we can represent the construct in the framework better using the digital technologies. We did not want to expand the construct as it was defined in the framework. What we wanted is to make sure that we represent it better using, again, the affordances of the computer. So for that, we needed to make some decisions on, okay, what is the appropriate system? How do we present the opportunities for the student to answer or to respond to the question? And also make use of, again, as I said, potentially what they call technology-enhanced item types to allow to capture student work or student responses in a ways that go beyond what are allowed in paper and pencil modalities. Okay, let me give you, this is one example. This shows you the platform. This is the NAEP platform, which is relatively simple. It has a toolbar that has some instructions for a student. It has a theming, which is like a student who has some visual difficulties, they can change the theming of the screen. They have a zoom in or zoom out feature, so you can make the text or the images bigger or smaller. It does have, as a universal feature, what we call a text-to-speech. Each of these lines can be read to the student if they decide to use the text-to-speech. They have what we call the scratch word tool, which is a tool for a student can either do work on the line or mark in the screen, whatever they want to mark. There is an equation editor, which is a palette that allows a student to enter expressions and equations and symbols when they have an open-ended response. And there is a calculator. Some sections of the assessment are available. The calculator is available through the section, and they provide for function calculator for grade 4, scientific calculator for grade 8, and scientific also grade 12, but it's moving to a graphing calculator in the administration that is coming in the next years. Okay, so this is an example of one item. But again, one of the things is how can we incorporate new interactions to allow the student to show what they know and can do? And I'm going to give you other examples, some of the interactions that were introduced to the assessment and how they allowed us to collect data themselves. So this is what we call, this is an example, this is called a multi-layer image. And this allowed a student to control which element of a complex system they want to see. For example, if you see here, they can select in the muscular only, and this is or the nervous system, or the skeletal system, or the circulatory system, or respiratory system, or so all of that. Or they can see more than one at a time if they want to. Again, in a more static environment, this is more difficult to present because you will have to present different images for the same type of information that is provided. Okay. Another one is what we call a multi-stage process stimulus. In typical paper and pencil, you could you can describe the situation and say, okay, hell, there is a nuclear reaction, and this is the way that particle can explode under the reaction. But under a digital environment, you could present it in more than one way. For example, you could have it entirely as a video. So it's an animation of exactly what the reaction is happening. It's more dynamic and potentially more engaging. Or you can have it in the stages. So you can, the student can click on the different states here. So you have the second stage when the particle explodes, and you can see the different states at different times. So you have the design decision to make, which one will be the more appropriate based on the expectation or what the item is trying to assess or do itself. This is another one. This is called the zone item. And you see here, this is where a student can click on a part of the image where they can select the part that corresponds to the question that they are asking. So they can select this part or not. It's for medical fields or for science, very useful item type, because again, it allows the student to not just describe it or select it by multiple choice, but highlight them in the image, what they need to do. We have been using what we call simulations, video simulations. So in that particular, a student can make observations, for example, and if they run it, they will see the iguana is moving here, and they can make observations and base the responses on the observation that they are making here based on the movement or the actions of the iguana in this particular case. They can also be used to represent complex systems. So like how Tom's in the animation that, complex graphics that have dynamics, movement into the thing itself. Yeah. Okay, so a couple more examples. Another simulation that provides a student, and this last two that I'm going to show, they are more about providing students opportunities to actually collect their own data. It's like they're doing the experiments on their own. Instead of giving the results of the experiment, they can experiment with the variables. And then by changing the variable, they can see different results. In this case, it's about erosion. So they can see how the different components of the different variables can impact the amount that they get in the eruption themselves. There's another one, simulation. In this one, a student can select variables and manipulate the variables and then see the result of the variable that they select. Okay, so they can go. They play the simulation and they select the variable, the type of ramp, the surface, and whatever, and they collect data. They can see the data that appears in the particular thing. So that, again, that allows the student to generate their own data before they answer the question themselves. So many opportunities, many affordances in the computer, but the main idea here is, okay, how do we go about making this in an appropriate way? So like in any other assessment, we start with, okay, the decisions about the construct. We have our foundation stones, which is a construct. So we want to measure the construct itself. So, and that's what we measure. So we don't want to change that. We want to represent it correctly. But now we have the decision to make, how are we going to measure that construct? We're talking about the design of the tasks and items that we put into the assessment. These decisions include everything from the structure of the task, the item type, the response mode, the surface features, the colors that we use, the font, the layout for the animations, and all of that. So there are a lot of decisions to make. And the thing is, this decision, because students do not think in a vacuum, they react to what they see. They have a potential impact on the way they answer the question. And that's what we need to be careful in terms of trying to understand how these features can impact the student responses. So how we measure it, and we're not talking about just construct irrelevant processes. So what we're saying is like, as more options you have for the student to interact with the items, that line between the construct and what you might want to measure in the construct and how to measure becomes more fuzzy itself. And we might, purposely or not, be introducing features that might be part of what you want to assess or you might not want to assess. For example, if you wanted to use an avatar to engage the students, motivate the student to respond, well, you might be introducing collaborative or communicational skills into the assessment. Is that okay or not? That's something that you need to think of carefully and decide. And that is why when we started to do this work with several years in advance, the transition to DBA started in happened in 2017, but it started way before 17 and continued to be investigated because we needed to make sure that the delivery mode do not impact the student behaviors in ways that might be inappropriate to allow us to get the student's ability estimate appropriately. So we wanted to see how this structure can impact student mental processes. And to do that, that's what we started to include as a regular part of our development process, cognitive scientists, people that were carefully looking at student behaviors in different ways. Could be cognitive behaviors, how this feature can impact perception or attention or the working memory load, or how they can impact the affective processes, engagement, motivation, enjoyment, frustration, boredom, or behavioral, the affordances for the actions that they need to do in the computer, or even social behaviors such as collaborative and communicative result. So all of these things are now coming into play a much deeper role that they used to play in paper and pencil, because now we are presenting a student with a dynamic potential stimulus, dynamic interactions. So the student can be either distracted or can be engaged more or less or on all of that. Just to give you one example of the possibilities of this, and this was done by what we call using process data. Process data is, in the computer, we have the opportunity to collect everything the student do in the computer, any clicks they make, the time they make in between clicks, the tools that they use, the frequency of the tool, the sequence that they go through the assessment. All of that log, we call it the log data, is collected and could be used to give us an idea of the profile of the students, give us an idea of what the student is doing in terms of behaviors during the assessment, and also in terms of potentially the construct itself. So we started to collect process data, and one of the studies that was done to address some of these things, in particular engagement, was a study about the level of, about what the students engage into the assessment. So the researchers here defined what they call an engaged interaction, which was based on the amount of time the student spent in the item. They create a threshold for the time. It's a method that is called the WISE method, which is like you take a threshold, potentially the average of that the student took, and you take a % of that average, and you set up that as your threshold to say, hey, did the student was engaged in the item or was not engaged? And what this study found out was like, based on the proficiency level, students at the below basic level, the students that were classified below basic in NAEP, actually has much less engaged interactions than the students at the other proficiency level. More importantly, some people have identified like 0.9 as the potential score distortion. If you have less than 0.9 engaged interactions in an assessment, in a complete form block, you might have some potential distortion in the ability estimation. And as you can see, it happened at all 3 grade levels of NAEP for the below basic student. There were less engaged interaction than the potential score distortion, which might be a little problematic for estimation of ability. Again, collecting this information or getting to this inference was only available after we were able to collect what we call process data, in this case, timing data. So how much time a student spent in each of the items, which again, a digital assessment environment allows you to do. But before we move on to the AI part, let me just give you one more example and talk about what other things NAEP are doing. This is an item administered in 2017. As you can see, it has two parts. I mean, we have a table. The students are asked to kind of create a pie chart representation, a circle graph representation of the table, which is a simple question. And then they are asked a question about how much greater is the percent of customer from clay than the percent of customer for table. Okay, so you have, again, complete this pie chart by dragging and dropping, and then answering a question about, computing a percent for clay, a percent for Taylor, and try to compute the difference, between those percents. So it doesn't seem that complicated, maybe. And the expectation is that the students will enter the item. Then when they enter the item, they will do the drag and drop action. And then they will do the computation to answer the question, the part B question. However, we look at how what the student did in terms of the actual sequences that they took in the assessment. And let me show you what this is saying, okay? This is, first of all, this is classified by achievement performance. So this is the student below basic, the first part of the table. The second part is the student that were classified basic, proficient, and advanced. So you can see in this sequence, I mean, the most common sequence for the below basic was the student entered the item, they did the drag and drop, but they re-entered the item, and they responded to the second part. That's 16%. The other 12% was they entered the item, they did the drag and drop, they left and re-entered the item again. Then they use the calculator to compute the percent, and they respond. Okay. The third large percent, I'm not going to read them all, but they entered the item, they did the drag and drop, and they responded. Okay. This number 3 is a student that apparently didn't have to re-enter. Then we look at the basic, and it was enter the item, drag and drop, re-enter again. That was the most common. For proficient, enter the item, drag and drop, re-enter the item. And even for advanced, enter the item, drag and drop, re-enter the item. And we were like, okay, wait. What is going on in this particular item that students are leaving and then coming back? Well, when we look, and this is one of the advantages of process data, this was in the pilot. This second part, they needed to scroll in the computer to see it. After the first part, it had a clear answer. What we call the fault of the item, when you don't see the screen anymore, you have to scroll. There is a scrolling bar. They couldn't see the second part. So process data allowed us to identify, oh, this is a potential issue here with the item, because students are showing that they seem to be leaving the item before they completed it. There are indicators in the toolbar that tell you that the item is not completed, and probably that's the reason why they came back to the item. But by process data, we were able to identify those things. We were also able to identify, hey, were the student using the calculator for the appropriate type of computation that they need? And let me show you an example. This is the below basic, again, basic, proficient, advanced. And this is the percent of the most common interactions or the most common computation the student did in the calculator. Okay? So below basic, you see, okay, one of the most common computation was 120 minus 30, which was the frequency. I mean, the frequency for the question, Clay versus Taylor. But there's no indication of percent. They just computed the actual differences, not the percent differences. None of this computation tell us something about the student were understanding how do you do a percent. I mean, they have something quotient here. We might indicate some relative size, but this is not a percent. For the percent, you need to find the total and divide the particular amount by the total. And there is no indication. Only like less than 0.5% of students try to find the total first, but they didn't follow up with dividing the particular value by the total. So at the below basic level, there was no indication of understanding of percent. The same happened at the basic level. We didn't see, based on this type of computation, there is no indication that is, very small one. Here they did 126 over 30, which is the wrong one. 30 over 126, there is a little indication that they were maybe thinking of the percent, but it's a very small percent. And this student did something that is not the percent first before they did that. So the first achievement level where the student seems to be getting some idea of the percent is at the proficient level, where you see some students have 30 over, well, 30, what is it, 126? 30 over 126, well, it's not, it's 126 over 300 is the one. You see here 126 over 300 and 30 over 300. This is where you start to see some students using actual percent approaches to answer. But it's a very small percent of the students use the calculator at the proficient level. And at the advanced level is when you start seeing which is the highest proportion of, among the interaction with the computers. You see the highest proportion we're trying to applying skills associated to percent. So this level of detail, which can allow you to do qualitative reporting or understand where the students are failing, I mean, cannot be obtained by response data only. The process data, which is behind the scene, allows you to do this. And this is only affordable in digital assessment. Of course, now we can use, and Dr. Matt will talk about that, AI approaches to, because this analysis doing by human or manually takes a lot of time, but with the use of AI, we might get much faster ways to get to this analysis that can provide teachers and even test developers opportunity to understand where the students are in these particular skills. Just two more slides before I move to Matt. The NAEP framework is now the other major change that is happening with the framework is with the NAEP assessment is that the frameworks are changing. In particular, mathematics, they are all changing. The science, reading, and math have changed, and they're going to be introduced in 2026, the next administration, the next spring. And they have changes in terms of what we measure and how we measure it. Okay, in terms of what we measure, one of the major shifts, in particular the math framework, is the focus on what they call the mathematical practices. So there is a stronger emphasis in the processes, the norms, the habits as practitioners do when they engage in solving mathematical problems. So it's not only about the content, but it's the process that you get to answer those questions. And they define 5 practices: representing, which is, recognizing, using, creating, interpreting, translating among representation; abstracting and generalizing, that has 2 components: decontextualizing and then extending or expanding. You given a situation, you decontextualize it mathematically, and then you might be able to expand it to other situations. Justifying and proving, which is about argumentation. It's pretty much creating, evaluating, and proving or supporting claims. Mathematical modeling, which is based on a modeling process. When you want to solve a real life problem, you engage in this particular process, which is, okay, you make sense of the situation. Then you identify the variables of the assumption. You make assumptions to make it amenable for mathematics. Then you mathematize it. Then you use the computation in the mathematical world, and then you translate back to the real world to provide a solution to the original problem. It's a process. And then the last one that they wanted to emphasize in the assessment was what they call collaborative mathematics, which is the social enterprise of doing mathematics with others. They define 3 measurable skills for collaborative mathematics, which is, the first one is making sense of the contribution of others. If somebody gives you an idea, you try to make sense of that idea. The second skill is evaluating that idea, if the idea actually helps us to the solution of the problem. And the number 3 is what they call responding productively to that idea, meaning I did implement the idea, or I revise it, or I just change it completely because it doesn't work. So these 3 measurable skills are part of the collaborative mathematics as described by the NAEP framework. And as you can see, the first 3 are more maybe skill specific. You can recognize a representation without doing the others, or you can create a claim without, proving it. But the mathematical modeling and the collaborative mathematics are processes, and they have to be followed in a particular sequence. You have to identify the mathematical problem that you're going to solve first. Then you probably mathematize it, and then you solve it with mathematics, and then you go back. So there is a process. And because of that, the framework calls out for different item types that they call a scenario-based task, which is those tasks that allows you to have multiple items based on the same goal, the same idea that you have to solve it, but allows you to go through the sequence of steps for either modeling or collaborative mathematics and solve. And I have one example here. This is just the introduction of one. So they said that what they call scenario-based task is, the defining features are they need to be authentic. They have a motivating question or task that they have to complete. And, it's an item or a task that support exploration, but it allows you to control, for example, the sequencing. You have a way to present the parts based on the sequencing. You can do branching. If a student go in one direction, you can branch it to a different place or the same place. You can label them. If they answer a part incorrectly, but you want them to see if they can continue, you can label them to say, oh, why don't we use this response or something? You can use techniques like that to allow them to control and don't get lost from the beginning itself. Okay. The other change is mathematical literacy. There is a more emphasis on mathematical literacy at grade 12. So the framework calls out for objectives that allows to assess mathematical literacy and the application of mathematics in situation of a person's life. Similar somewhat to the PISA definition, but not identical. And it has these two parts, the content or the skill, and also the type of context in which you're going to apply the thing themselves. In closing, I just want to give you this image, which is like, this is part of our current development team. And you can see that the skill sets of the item writers and developers have changed significantly when we move from paper to digital. We need to work closely, as I said, with cognitive scientists, with process data analysts, with UI UX designers. We need to do a lot of pre-testing activities, play testing, and usability studies to make sure that this is working. And what this tells you is that the digital assessment are no longer just about what the student know. They're about to get information of how they think and how they engage and how they do problem solving when they are in the face of a particular stimulus in an assessment. With the new NAEP framework, the focus on process and dynamic interactions, we are not just observing outcomes or responses. We are capturing learning in action itself, like in motion itself, and to truly, evaluate that and appreciate that, the power of this data can have. We must bring together cognitive scientists, process data, content experts, and other specialists, accessibility specialists. Again, not just to measure learning, but to understand it and potentially shape it for the students. Thank you so much. And I'm going to stop sharing and I'm going to pass it on to Matt, which will continue now. AI is coming to the place. So how we, in top of all of these changes, how AI can change some of the approaches that we, and Matt is going to talk about how ETS is approaching the introduction of AI into our assessments. Thanks.
Hello, you see my slides and hear me all right?
Yes.
Yes.
All right, fantastic. Yes, thanks, Luis. And I just want to reiterate what Luis started with, which is a very big thank you for inviting us to present to you today about some of our work around digital-based assessment and the use of AI in assessment. What I prepared here today is a fairly high-level presentation. I'll go kind of intertwine some of the things we're doing on the research side with some of the things and say a few words about what we're doing operationally as well. So, a lot of times when we discuss AI and assessment, some definitions you read of AI suggest we've been doing AI for assessment for a very long time, things like item response theory. So I always like to start with kind of the definition that I kind of use to kind of set the stage for myself. And that's one from OECD from 2024 is this specific version, which says AI is a system, is a machine-based system that for explicit or implicit objectives infers from the input it receives how to generate output such as predictions, content, recommendations, or decisions that can influence physical or virtual environments. And they can differ in the levels of autonomy and adaptiveness they have after deployment. And that's why I said it feels very much like much of what we do in educational assessment is very close to this definition. But we'll take the more modern view of AI and specifically focus on kind of more like the generative AI today. This Venn diagram is kind of adapted from one of my colleagues' papers on AI literacy, specifically, with a focus on AI literacy assessment. And this takes the view that AI is kind of a very broad set of tools that includes machine learning, it includes large language models, and it includes generative AI. So just a few words here about how I think about it. Machine learning is anything kind of predictive, any sort of predictive algorithm. Language models are very much what we think of like ChatGPT, where the AI is very text focused. They also tend to be generative in the sense that ChatGPT is generating text, but there's all other types of generative AI as well, such as those that generate images or audio or video. So this just kind of gives a sense of kind of how we think about the different kind of flavors of AI. So what does AI bring to assessment? And this is what my colleague likes to use in his presentations, and I borrowed it from him. And it's the 4 S's. So AI brings to assessment speed, and that's the one that is one that is ever present. So being able to use AI in assessment allows us to do things more quickly. So we can develop tests more quickly, we can score tests more quickly, we can provide feedback more quickly. And so AI has the promise to kind of speed up the whole assessment process. It also allows us to scale assessment, because if you think about scoring, for example, it might take a human rater of an essay 3-5 minutes to score an essay for a student. In that same 3 to 5 minutes, AI, depending on which kind of approach you're using, can score tens of thousands of essays. So it allows us to really scale. It's both speed and scale, because the cost is also reduced. The other thing it allows, the other S, a third S, is synthesis. So it allows us to bring together multiple sources of information to draw our inferences. So in assessment, what does that mean? We have some of the things Luis was talking about. We have process data, we have response data, we might have other data available to us. We're able to bring all of that data together and use AI to synthesize it, to make richer inferences about what students know and can do. And then the fourth one that my colleague likes to say, surprise. Every day when we're doing stuff with AI, we're surprised. We're surprised by some of the new things it's able to do that we didn't think would be possible. I'm often surprised at some of the stupid things it does, or the hallucinations it manages to come up with. And we're also surprised by how challenging it can be. So given the 4 S's and given our goal of understanding how AI is used in assessment, so what are some of the most common areas, or what are some of the most common uses of AI in assessment? And these are what I would say at ETS, these are our 4 most common uses of AI kind of in the actual assessment process. And just a caveat that they're not all used for all of our testing programs. So, for example, automated scoring we use for some programs, but not for others. For example, NAEP is exploring it, but we don't do the scoring for NAEP. Another contractor does that, but they're exploring it at this stage. It's not done officially yet. The second kind of common area that AI is used for assessment is in test development. Automatic item generation, for example. It's very easy to generate new items with a prompt and can generate items. You can generate reading passages. You can generate images to go along with items, graphs to go along with math questions, etc. A third area where it's used quite extensively, both within ETS and more broadly, is for cheating and plagiarism detection. So trying to identify individuals who are kind of cheating on an assessment or on the homework assignments and such. And finally, one that Luis was talking about a little bit towards the end of his presentation, behavioral analytics and process data analysis. Really, now that we are, like Luis said, now that we're collecting this data, we have all this rich log process data that we're capturing as part of the digital assessment. We're able now to dig in and try to use that to understand students' behavior and associate that with things like their responses. So now what I'd like to do is just kind of take a couple minutes on each one of these and kind of discuss a little bit of details about them and some of the pros and cons associated with each of them. And then after that, I'll say kind of where things are trending. What are some of the kind of next things on the horizon that we're investigating in our research? So let's start off with automated scoring with AI. So automated scoring has been something researched at ETS, and well, it's been researched in the US for nearly 60 years, using computers to automatically score essays and other written responses. I would say at ETS, the research into automated scoring really accelerated about 25 years ago. Obviously, what automated scoring looked like 25 years ago versus what it looks like today are very different. But all of automated scoring basically works the same way. So we have response data, and the typical example is we have a student's essay that we want to score. From that essay, we have some method to create features. Basically, take that written response and turn it into a bunch of numbers. And really that first step, that first arrow going from response data to features calculators, or the feature calculators themselves, those are really where all of these methods differ the most, is how do you turn that essay into a series of numbers? That series of numbers is the feature matrix. That goes through some predictive model, and there's many that people explore. And out from that predictive model comes a score, which we attempt. Usually the approach is that our predictive model is built to try to predict what a human would assign to this essay. So some examples of kind of automated scoring. As I mentioned, the kind of prototypical example is automated essay scoring. Now, historically, that used a lot of natural language processing. So let me go back to this figure in that feature calculator. So natural language experts they had algorithms to calculate features associated with elements of the essay that are meaningful for the rubric. So our E-rater, for example, has features related to grammar usage that natural language researchers came up with. They had other features that they built based on how well the essay is developed and so on. So in the kind of the 20-year-old version of automated scoring, you had natural language experts who built features, painstakingly built features that they believed mapped well to the rubric, and then those were used in predictive models, usually something as simple as a linear regression model. So that's kind of the E-rater, what we use in our E-rater. Then we have speech is another place where we use automated scoring. So speech on our TOEFL tests, for example, we have candidates who respond to questions through a microphone that is recorded, but it more or less works the same way. That audio file, kind of natural language experts took those audio files, created features that they believed or map well to the rubric, which is then used in a predictive model to predict human scores. Now, move forward a little bit further to automated scoring of short constructed responses. So now think of an item where the response might be one sentence long. It's not a full essay. And where we don't even necessarily care whether it's written particularly well. But where we're not really interested in writing, in assessing the writing quality, it's more about the content of what they've written. So the typical example here is in a reading assessment, a student reads the passage and they're asked some question, let's say, what's the main topic of the passage? And, that might be a sentence long. Some students might capitalize, some might use punctuations, others may not. So 10 years ago, we developed a scoring algorithm based on what are called n-grams, both letter and word n-grams. And that's just basically sequences of letters or sequences of words. And you just do counts, like how many times did this sequence of letters appear in the response, or this sequence of words appear in the response. And that was used in a predictive model. It's not very interpretable because it's just, you're trying to get at words and, things like that. But in some cases, it did quite well. Well, what's now called Neural Henry is kind of taking that next step, building off of large language models. So a common one is BERT. BERT is a kind of a precursor to some of the language models, generative models that are out there today. That does a more sophisticated way of taking a short response and turning it into a vector of numbers. Sometimes it might be, thousands of numbers for each essay. And it's meant that vector of numbers is meant to kind of contain the meaning of the response. And then that's used in a predictive model. That's what we're calling our Neural Henry model at ETS. Move to today. So that was, being explored maybe 5 years ago, kind of before ChatGPT came out. But now today is what we call, what you can have zero shot, or I should have probably mentioned also few shot, which is If I had more time, we could just do an example of it here. I simply can put in a response, send it to GPT, and ask GPT to score it according to a rubric I provide. And that's zero shot. It's very easy to do, but of course, it doesn't mean it's a good thing to do. So obviously the benefits, we've talked about this, are efficiency, consistency. Some people think that's important. More or less, if you give it the same response, you're going to get the same score, unlike if you give it to random humans, you're not guaranteed to have that, and the scalability. But there are many dangers in using some of these approaches. So bias and fairness often creep in. So sometimes AI will pick up on things that are associated with good performance that aren't actually indicative of good performance. And a good example of this that I like to use comes from my own research, which is we found that one demographic group in the US was being unfairly given an advantage by automated scoring algorithms. And what did we find is that this demographic group tended to be more likely to repeat the question when they answered when they gave their response. So what is the major theme of this reading passage? The major theme of the reading passage is, and then they would give their answer. And just by repeating their prompt, the algorithm finds that that's associated with good performance, and so it gives them a little bump, even if what they said after repeating the prompt was nonsense. So there are these things when you use these predictive models that can sneak in. Things like zero shot and modern language models, we have to worry about lack of nuance. These are built, language models are built on language that's available on the internet. If you are scoring a fourth grade student, the language they use is going to be very different than what some of the language models were built on. And of course, lack of transparency, and then of course, lack of or undervaluing human judgment can be a problem. A second major place where AI is used is in automated test development. And this is a flow chart that our kind of major researcher in AI for test development is provided to me. So, and he likes to say, yeah, so it's gotten really easy to generate items. You can generate hundreds of thousands of items a day, millions probably. You can generate millions of test questions a day if you really want using generative AI. But you can't possibly pre-test them all if you generate 1 million items. So what are you going to do? Well, you have to, so the next step is to use AI again. So you use AI to generate items. Now you're going to use AI to evaluate them and potentially pre-test them, although I don't believe in that myself, but to at least get an idea about how the items may perform. Now you develop a form. So if you could, estimate the difficulty and know how discriminating an item might be, you could assemble a form. But now you have to worry about, you don't want the form to have items that are too similar to one another. So you have to have another AI agent that's maybe looking at the similarity of items before you create a form. And after you do all that, you might not even have out of that million of items, you might not have enough. So you have to go back and the loop starts all over again. So that's kind of the big problem. The simple problem, how do you generate items? So again, historically, automatic item generation used template-based methods. And this works well for very structured item types. Vocabulary exercises, basic math questions, things like that you can basically set up a template and just kind of interchange different words or different concepts And again, this is something ETS was doing 20 years ago, template-based methods for math questions especially. But today, we can use purely generative approaches. We can use advanced AIs just to create unique and diverse test content that's capable of producing more complex and varied items. And we potentially can have a broader range of item types and contexts. So I've kind of already touched on the benefits. The pitfalls I've kind of touched on as well. Quality control is difficult. Reliability can become an issue because now you're generating items. You haven't really been able to pre-test all of them. And so there's extra uncertainty there. Bias or inappropriate language you need to worry about creeping in. Or certain types of items get overused just because that's what the AI generates more of. And that can create bias if it's associated with demographic groups. So again, it's relatively easy. First step's easy, but how to do it well is not so easy. The third area I'd like to discuss is the proctoring and ensuring academic integrity with AI. So this is quite commonly used now, especially when individuals are allowed to take exams at home. That AI sensors are used, microphones, cameras, and other sensors are used to monitor students and try to detect whether or not they're cheating. And that's in real time while they're taking the test. After the test, AI is also used to look to see if there's plagiarism, if someone's written an essay and they just simply copied from someone else, or maybe there's collusion between multiple students who turned in very similar essay responses. So how do you use AI to detect these sort of things, especially if you have a large scale test where you have tens of thousands? How do you look for those similarities between pairs of items if you have to look at 10,000 choose two? What is that? I don't know. It's like a billion combinations that you would have to look at. So how do you do that effectively? Well, AI can help us do that. And the goal here is really to use AI to ensure that others who don't cheat aren't negatively effective, but to do it in a way that's fair to everyone. So same sort of things. I'm probably starting to sound a little bit like a broken record. So benefits, scalability, consistency. So we can monitor large number of test takers simultaneously. Consistency, we're providing a uniform monitoring tool that's not different depending on students. And by able to do this at scale, the goal, the hope is that we'll scare off cheaters. But of course, this can be very intrusive. If I have a camera pointing at me while I'm taking a test and I'm in my home, that can be intrusive. There's accuracy issues. There's false positives, false negatives. That can lead to unfair consequences, especially when they're associated with different demographic groups. It can increase stress and anxiety. So now you've increased stress and anxiety. Students are less able to show what they know and can do because they're stressed out about this thing, watching every move they make and whether they look down on the floor, if that might set off the flag. So again, it's similar. You'll see the common theme. There are some benefits, but there are a lot of things we need to worry about. And then Luis discussed this a little bit, behavioral analytics and process analysis. So really here is we're trying to look at the student interactions with the digital assessment and using that for various purposes. And so what's nice about this is it's more than just knowing their final answers. It's how do they got there. And Luis discussed that a little bit. So tracking how students interact with item, analyzing patterns in their problem solving. Luis showed some of that kind of manually. We see that the below basic people never really even looked at ratios when they were calculating a percent. And from this log data, you can infer strategies and other cognitive or metacognitive. If you were doing like Luis did and looked at these things very manually using human labor, it becomes very expensive, very time consuming. If we can train AI to do this, we can do it at scale. And here's an example of some research. I mean, it's just to give you an idea what this weird little plot means. This is some research Luis and I are involved with. This scatter plot here it takes data from NAEP. It looks at timing data, how often students visit items, how they performed on items, what virtual tools they may have used, calculators, etc., and then tried to find a kind of a low dimensional representation of this high dimensional data and to try to find some common groupings of students. And sure enough, when you do this, you see some of the things that Luis was discussing. Oh, well, this group, I don't remember which group it was, but there was a group that maybe was using calculators in inappropriate ways. They were using calculators on items where you shouldn't be using calculators. And you can find things where digging through that with the naked eye is very difficult, but with AI, it can really help you speed up this kind of examination. So process data analytics, so similar sort of things. You get more insight. We can do things like identify if a student's kind of veering off path, which we have other researchers who look into nudging students if they appear to be going off path. What can we do to get them back on path in the assessment, and so on. But it has very similar kind of potential negative consequences. So I know I'm hitting the 30-minute mark, so I'll just kind of end here after a couple slides. But the main thing with this slide is the list of AI uses just continues to grow. So everything I mentioned so far at ETS, we use in one operational program or another, not necessarily all of them, but we use them somewhere. These are kind of more of the things we're doing on the research side. We're still doing research on everything I've presented so far, but this is solely research. So one example is conversation-based assessments. And now you have, for example, GPT has something, or OpenAI has something called real time, where it's a generative model that you can essentially have a spoken conversation with, and you can build this so that it has a conversation-based assessment. This can be used for example, we have a colleague who looks into this to look at teacher practices, where you have a human teacher who's interacting with a virtual 6-year-old to try to see if the teacher can extract from the 6-year-old their strategies for solving a simple addition problem. And this is built to be kind of to see if the teacher is using the best practices, so that if they're not, they can be given feedback. Gamified assessment. We're not too active in this area right now at ETS, but there's a company, Roblox, that maybe you've heard of if you have kids, probably. They do some gamified assessments, especially of things like critical thinking. Virtual and augmented reality assessments are, again, we're not doing a lot of that at ETS, but that's another area where AI is becoming increasingly important and explored kind of research-wise. So I just want to, one last thing here. So as you notice, I mentioned a lot of benefits, but a whole lot of potential pitfalls. And that's why the number one lesson I'd like to leave you with is that using AI in testing, in assessment, requires responsible use of AI. And this kind of strange figure I've created here is kind of my synthesis of a number of different frameworks for responsible AI. And the thing that I probably want to spend just a moment on is the kind of upper right corner, which is the educational impact and integrity. And that is, you know, we try to make sure that when you're using AI, it's to improve something. It's not just for the purpose of AI. It's to improve something. Now, sometimes that might be improve the cost of an assessment, but it really needs to be aligned to, it needs to improve the assessment, and it needs to be aligned with the goals of the assessment. Like Luis said, the construct is central. We shouldn't change the construct just so we can use AI scoring, for example. So with that, I will stop the presentation. Here are a few papers, a few kind of white papers, kind of related to this work. I'll leave it up there for a minute if you want to grab the QR codes. So thank you.
Muito obrigada, professor Matt, and muito obrigada, Luiz. Foi excelente, foi muito bom. Eu realmente estou bastante impactada com a apresentação de vocês, ao ver todos os avanços e novos desafios que o NAEP está enfrentando e que o ITS, tudo que o ITS está desenvolvendo. Eu passo então a palavra agora, muitíssimo obrigada. Eu, por mim, continuaria até ouvindo vocês. Eu passo a palavra agora ao professor Francisco Soares, depois ao Rubem e à Marinês. Professor Francisco Soares. Chico, você está sem som e sem câmera.
Desculpa, porque mandou. Agora sim. Maria Helena, muito obrigado pelo convite. É uma honra estar aqui ao lado desses colegas brasileiros, a professora Marinês, o professor Rubem, a Priscila, naturalmente você, e ouvir os dois profissionais do ITS, o Luiz, que já nos visitou de outras vezes, e o Métio, ambos nos brindaram com, como você disse, apresentações muito, muito interessantes. Eu queria começar contando, a gente considerava isso uma piada quando eu estava fazendo doutorado, que uma pessoa foi acusada de alguma coisa no Texas, e o nome dessa pessoa era John Smith. E, como vocês sabem, o Smith é um sobrenome extremamente comum de pessoas que eram mais simples. E aí o clerk da corte abre o processo e diz: Now the state of Texas against John Smith. E que o John Smith teria dito: What a majority? Quer dizer, o que eu, um mero John Smith, vou fazer contra o estado do Texas, que é aquele estado enorme e muito rico? Eu tive esse sentimento porque nós estamos tendo uma apresentação do ITS. O ITS é a grande referência e, como o Matthew falou várias vezes, na área de pesquisa, mas também não só na área de pesquisa, mas também na área de grandes contratos. Quer dizer, de fato, o que nós temos aqui é uma exposição daquilo que está sendo feito. Pois bem, mas nós estamos aqui no Brasil, num outro lado, queria fazer algumas observações. Eu vou fazer essas observações a partir de uma experiência que é uma experiência pequena que nós temos no contexto da Fundação Getúlio Vargas, que está apoiando o projeto, mas junto com o meu colega da Universidade Federal do Ceará, que é o professor Jorge Lira. Então, o que a gente está fazendo é um esforço de fazer avaliação formativa. Eu vou falar apenas da avaliação formativa de leitura, porque Jorge falaria de matemática. Quais são os problemas que a gente enfrenta? Vamos observar que a ideia não se usou exemplos de textos de leitura. Perceba, o professor Valdívia usou muito textos de ciência. Porque, de fato, os itens de ciência colocados no computador com simulação, muda-se completamente o jogo. Ou seja, você pode verificar se o jovem, se a criança, de fato está dominando. No caso da leitura, isso seria mais simples, porque nós precisamos de um texto e é sobre esse texto que algo vai ser feito. Ou seja, eu posso fazer uma boa avaliação de leitura com papel e lápis, sem problema. Mas onde está a diferença? É na devolutiva. Ou seja, nós precisamos, quando eu estou falando de avaliação formativa, nós estamos precisando ver o que o aluno respondeu e construir uma resposta, uma devolutiva para aquele aluno. Perceba, nesse sentido, as experiências que a gente tem são, como eu disse, são muito pequenas. Eu acredito que elas estão aceleradas. Eu acredito que no princípio do próximo ano a gente terá coisas mais concretas para mostrar, mas é muito interessante a gente treinar um modelo para, a partir do que o estudante nos deu, e, no nosso caso, a partir do texto, dizer o que aquele estudante deve receber de orientação. Isso só pode ser feito com inteligência artificial. Caso contrário, a gente voltaria àquela ideia que muitos de nós tivemos, mas que não é viável em escala, como o Matthew falou várias vezes, que é atender todos os alunos. O Brasil adora exclusão. Então, nós temos alguns poucos alunos cujas respostas podem ser lidas e comentadas. A grande maioria dos alunos não pode. O que isso tem levado? Tem levado a uma situação extremamente incômoda para vários de nós, que é a redução da avaliação a itens de múltipla escolha. Quer dizer, o que a gente aprende vendo o Valdivia apresentar aqueles itens é que esses itens de múltipla escolha, eles são extremamente limitados, seja para o uso, seja para verificar o que o aluno aprendeu, mas principalmente para dar a chance ao aluno de aprender melhor, né? Então, a experiência que a gente tem, ela é muito boa nesse sentido, mas ela ainda é muito precária. Onde nós já caminhamos mais, que é na correção. Tem uma parte inicial que é ler o que o aluno escreveu e transformar isso em arquivo. Perceber, e no Brasil ainda a grande maioria das avaliações são feitas em papel e lápis, isso deve ser lido, e aquele texto do aluno deve ser então transformado num arquivo, num string, que possa receber a análise de Natural Language Programming. Há muito desenvolvimento nisso, e é muito interessante verificar como que os estudantes têm quase um dialeto próprio. Quando a gente consegue ler o que eles escreveram e comparar com o léxico da língua, a gente vê que isso é quase um dialeto próprio. Esse é um problema que tem muitos resultados. Agora, quando nós vamos corrigir, nós temos feito uma experiência e que, ao invés de pedir a máquina para corrigir, nós vamos pedir à máquina para aprender a correção de um conjunto de humanos. Que isso? Porque nós estamos interessados também na formação do professor. Quer dizer, um risco muito grande que a gente está correndo é achar que a AI ela vai se desenvolver tanto que a gente não vai precisar mais de professores. Eu não sei o que o mundo nos espera, o futuro está nos reservando, mas, por enquanto, a gente acredita que os bons professores e os professores que nós temos, potencializados por boas capacitações, são essenciais. Então, tem sido muito, muito interessante quando a gente coloca os itens para os professores e coletamos deles as respostas. Nesse caso, a gente trabalha com um tipo de classificação muito simples. O estudante, pela visão do humano, não produziu uma resposta adequada, ele produziu uma resposta semi-adequada e produziu uma resposta adequada. Lembrando que aí não vai ter a resposta certa, mas eu vou ter várias respostas adequadas e vai. Na realidade, o que a gente observa é uma enorme variedade de respostas inadequadas. né? As pessoas erram com produzem respostas inadequadas com uma criatividade incrível. Então, essa dimensão da gente juntar da escala também à capacitação, eu acho importante que ela apareça, né? Aquele slide do Matthew, usando um pouco de diagramas de Venn, ele é muito, muito interessante, porque ele coloca a machine learning como um grande ambiente. Tem muitas das coisas que hoje nós estamos chamando de inteligência artificial, elas já estavam disponíveis através de modelos, modelos estatísticos, modelos psicométricos. Mas é interessante que hoje tudo isso está junto e está enormemente facilitado. Tá? E o outro ponto que eu queria chamar a atenção é na questão da produção de itens. A primeira coisa que a inteligência artificial está nos permitindo, e eu vou me restringir novamente à leitura, é a gente sair. A leitura exige um texto. E aí, o que a inteligência artificial generativa está nos permitindo? Que é responder uma pergunta importante. Quais são as perguntas que devem ser feitas aos estudantes para que nós tenhamos evidência que eles compreenderam o texto? Eu não sei se eu consigo ser claro aqui. O que nós queremos do estudante através dos testes é compreensão leitora. O Brasil não faz isso. O Brasil testa habilidades isoladas, né? Mas a inteligência artificial está nos dando chance de criar um conjunto de perguntas em cima de um mesmo texto. Nesse sentido, como o Matthew observou, os avanços são muito grandes. Eu resistiria muito à ideia de gerar os textos. Eu acho importante que a gente use textos autênticos, mas essa é uma questão do lado. Mas o apoio da máquina para fazer isso é muito importante. Maria Helena, o mundo está mudando. A gente tem que mudar junto. A inteligência artificial veio para ficar. Mas a gente não deve perder de perspectiva que o grande objetivo é que o aluno aprenda melhor e não que eu meça cada vez melhor onde ele está. Porque no Brasil, nós vamos medir cada vez melhor a posição inadequada que o grande conjunto de estudantes brasileiros tem. Então, a gente tem que colocar uma dimensão de apoio ao aprendizado nesses esforços. E aí, nós todos que estamos na avaliação vamos concordar que está na avaliação acaba na sala de aula. Quer dizer, aqueles itens maravilhosos que Saldivia mostrou, se aquilo está na avaliação, a sala de aula vai ter que mudar. Os nossos itens de múltipla escolha, os itens de alfabetização que estão nas nossas provas, levam o Brasil a gastar toda a sua energia, recursos, tempo e atenção na produção de um conhecimento que não é o conhecimento que esse mundo que a gente está vivendo exige. Então, muito obrigado. Nós temos que incorporar aí a partir dessa posição de John Smith. Aqui tudo é mais difícil, os recursos são muito, muito menores e nós somos muito poucos, né? Mas estamos caminhando. Muito obrigado.
Obrigada, Chico, muito obrigada. Rubem Klein, professor Rubem Klein. Rubem, abre o microfone e a imagem.
Quem deve falar antes, eu ou a Maria Inês?
Tanto faz. Marinês quer falar antes? Oi, Marinês. Fala, Rubem. Fala você, depois entra a Marinês. Você quer
Tudo
falar
bem.
antes, Marinês?
Posso falar? Me deram essa ordem? Vamos lá, então.
Tá.
Eu quero engatar um pouco na conversa do Chico, dizer que foi um prazer muito grande ouvir o Matthew e o Luiz, mas eu gostaria de falar um pouco dos itens de múltipla escolha. Eu tenho estudado, assim, com muito prazer, porque eu gosto de estudar. Eu tenho aulas de inteligência artificial e a cada semana eu me surpreendo com os recursos possíveis para serem usados nas avaliações. É lógico que eu tenho que registrar que nós não temos os recursos de animação para fazer simulação dentro dos testes, nós não temos esses recursos tecnológicos. Mas eu fiquei gratamente surpresa com o Gemini e o Perplexity. Mais do que isso, quer dizer, quando eu dou a ele uma tarefa de elaborar um item para mim, eu dou o contexto, ou seja, são alunos, no caso, da educação de jovens e adultos, da periferia da cidade, de um nível socioeconômico baixo, né? Com uma linguagem absolutamente restrita, e eu quero que você estabeleça uma situação, problema, para avaliar tal habilidade. E quando eu recebo o item, eu peço o item de 3 alternativas e já fiz um de 5 também. Os itens são absolutamente muito bem feitos. Eu digo isso porque eu passei os últimos 20 anos treinando pessoas para elaborar item, para fazer ajuste de item e para elaborar matriz de avaliação. Muito bem. Aí eu peço para o Gemini para ele me dar a explicação do erro, porque como boa piagetiana que sou, a análise do erro, para mim, Chico, ensina mais. Bom, o acerto acaba com a conversa, mas a análise do erro começa uma conversa nova. Num primeiro momento, tanto o Perplexity como o Gemini me deram uma descrição do erro. Aí eu volto e digo, mas eu não quero isso. Eu quero entender, eu quero que vincule com a habilidade avaliada e me explica onde foi o erro. Olha, eu já elaborei mais de 400 itens de língua portuguesa, com textos grandes, próprios do currículo que está sendo veiculado, e também os itens de matemática. Então, a minha pergunta para os colegas, o Métio e o Luiz, é o seguinte: é lógico que eu tenho uma curadoria, eu tenho os especialistas em língua portuguesa e matemática que olham para essa produção, que é rapidíssima, tá certo? E dizem para mim os acertos, que são muitos, são 90% de acertos e 10% de necessidade de acertos, eu diria que é mais de linguagem. Minha pergunta esta é uma maneira de nós substituirmos o teste empírico pela dificuldade do item? Ah, esqueci de dizer, eu peço 3 itens, um item fácil, um item de dificuldade média e um item difícil para aquela população. Então, minha pergunta é para os colegas, ilustres colegas que nos brindaram nessa tarde, se nós aprimorarmos bem essa utilização de recursos, inclusive com itens de resposta construída pelo aluno, nós vamos substituir o teste empírico dos itens para as avaliações, e aí poderemos confiar, teremos a confiabilidade da adequação da medida para a interpretação dos resultados?
Obrigada, Marinês. Eu vou retornar depois para o professor Mete, para o professor Luis Saldivia, e antes vou passar para o professor Rubem Klein. Rubem, obrigada, Marinês.
Em primeiro lugar, gostaria de agradecer a Maria Helena, a Patrícia, a Fundação Instituto Ayrton Senna e Fundação Itaú Social por esse convite, né, que também, como o Tico falou, me honra muito estar na presença de todos vocês e poder assistir essas 2 palestras foram extremamente interessantes, né? A do Saldivia e a do Johnson. Quer dizer, a gente vê os recursos, né? Quanta coisa diferente tem sido feita e os recursos para tudo isso, né? Que nós temos, como a Maria Finês falou, temos certas dificuldades. Mas eu sempre pergunto, que eu acho que a mudança para avaliação digital trouxe novas oportunidades em termos de análise, em termos de itens, em termos de estrutura, e muita coisa, bem diferente do papel, né? Papel e lápis. Mas eu fico me perguntando, quer dizer, sempre uma preocupação que eu tenho, como é que se um aluno preocupa aqui no Brasil, né, tem muitos alunos que as escolas não têm computador, não estão acostumados com computador. Quando eles pegam pela primeira vez uma tela e algo mais complexo que eles têm que mexer, interagir com a tela, com o computador, etc., como é que eles se comportam? Né? Quer dizer, eu acho que tem que haver muito, por exemplo, todos os exemplos lindos que o Saldivia apresentou, né? Seria interessante isso tem, de alguma maneira, chegar à sala de aula, né? Para o aluno estar familiarizado e melhorar o aprendizado e tudo mais, né? Eu acho que isso aqui é uma coisa que eu não sei como isso está nos Estados Unidos hoje em dia, se todas as escolas têm esses recursos, né? Os Estados Unidos é um país muito mais rico e muito mais recursos que o Brasil, mas como é que isso está? Mas aqui a gente ainda tem muitos problemas, né? E eu me pergunto, né? Quer dizer, eu tenho visto exemplos do itens do NAEP, do PISA, né? Que são exemplos bonitos, mas eu pego um aluno que nunca viu isso antes e chega num teste, ele tem que lidar com isso, se, como é que ele se sente e o que ele consegue fazer no tempo, né, que é razoavelmente exigido, né? É um tempo, os nossos alunos estão acostumados com bastante tempo para fazer as coisas, né? Uma pergunta, uma dúvida que eu tenho. Agora, eu acho extremamente interessante, né? Por exemplo, o que a gente vê, como a Maria Affini falou, análise de erros, a múltipla escolha, a gente vê isso, os alunos fazendo, o exemplo do Saldivia, mostrando como o aluno processa, como é que ele resolve o item. A gente, quer dizer, eu estava olhando ali, vendo alguns dos erros comuns, né, que os alunos, a gente vê que os alunos cometem, né? Então é interessante, né? Quer dizer, essa interação pode, inclusive, ajudar bastante a produção, né, de itens de múltipla escolha. Mas hoje em dia isso aí está sendo feito, né, pela máquina, grande produção, grande quantidade de itens gerados automaticamente. E o grande problema, como o Márcio falou, eu diria, é a calibração. Quão bons são esses itens e porque ele vai usar uma avaliação, como é que eles se comportam, né? Quer dizer, eu acredito que tem que haver uma boa checagem, né? Porque a gente monta a prova baseado nos parâmetros das qualidades que a gente deduziu de alguma maneira, né? Mas eu acho que isso tem que ser bem checado, né? Mas eu acho que isso aqui é muito interessante. Eu achei, quer dizer, essa análise do processo, dados de processo, do dados do processo, muito interessante. Eu acho que acompanhar isso é bem interessante, né? Eu acho que tem muita coisa aí para a gente fazer e para acompanhar. Como Maria Helena falou, né? Quer dizer, o NAEP foi uma fonte de inspiração no início do SAEB, nossa Avaliação Nacional, e agora a gente tem que continuar a se inspirar no NAEP, no PISA, nessas avaliações, outras avaliações, para fazer as mudanças que a gente tem que fazer aqui no Brasil. E isso exige, eu acho que, como a gente vê, um trabalho de equipes bastante grandes. Uma pessoa sozinha não faz, né?
Nada.
Precisa de bastante investimento que é extremamente importante que seja feito, né? Eu acho que a gente tem que caminhar para melhoria e, há muita coisa para avançar. Agora, eu acho muito importante a gente pensar muito nessa questão da sala de aula. Eu acho que tem que chegar lá, como o Chico falou, tem que chegar o professor, tem que aprender a usar, tem que aprender a analisar, e aí as ferramentas têm que chegar, né? Para a gente poder realmente ter uma avaliação, que eu diria, mais fidedigna, mais efetiva. Então, obrigado.
Muito obrigada, Rubem. Luiz e Matt, eu vou fazer uma pergunta rápida para vocês, antes de encerrar aqui, para dizer o seguinte: primeiro, que eu gostei demais da apresentação de vocês, fiquei literalmente impactada com os avanços do NAEP, considerando que em 1995, quando nós mudamos o SAEB, nós procuramos fazer uma aproximação muito grande entre o SAEB e o NAEP. E agora eu vejo que existe uma distância enorme entre o que já se faz no NAEP, com os testes que o Luis Saldivia apresentou, com os avanços do professor Metz, né? E o que nós temos hoje no SAEB. Então, a distância é enorme. E me chama muito a atenção a ênfase que vocês deram à transição do modelo, que é um problema que nós, no Brasil, vamos ter que enfrentar, né? Nós estamos ainda com um modelo de SAEB muito tradicional. Ele ficou bem para trás, digamos, né? São testes de múltipla escolha, não tem atualização de matrizes, não tem inovação tecnológica, né? O SAEB ele se expandiu quantitativamente, é uma avaliação censitária, mas ele não evoluiu do ponto de vista nem conceitual, nem metodológico, nem tecnológico. Eu acho que são muitos desafios pela frente, aos poucos precisaremos enfrentar. Então, eu gostaria que vocês falassem um pouco aqui, a partir dos comentários dos nossos convidados, né, um pouco sobre essa questão da transição, né, como é que isso foi feito, porque eu imagino que o Brasil deverá enfrentar essa transição. E a outra coisa é que numa live que nós fizemos recentemente com o André Schleicher e com o Tiago Caliço, da OCDE, ficou muito evidente a necessidade de integração entre avaliação formativa e avaliação em larga escala, somativa externa, né? E agora eu vejo que vocês estão caminhando nessa direção de integração entre avaliação da aprendizagem, avaliação formativa e avaliação externa, somativa, né? Então, como é que é isso hoje? Quer dizer, o NAEP é capaz de ter uma devolutiva pedagógica para apoiar a sala de aula, considerando as profundas mudanças que acontecem hoje no contexto da educação no Brasil e no mundo, né? Porque hoje não existe mais uma separação. Os níveis são diferentes de aprendizagem, mas está todo mundo enfrentando desafios parecidos. Com a palavra, os nossos palestrantes, Luis Saldivia e Metz.
Matt, you want to start?
Sure. I will start.
And then I continue. Yes.
Yeah, so I mean, I will start with a couple of comments from Marinaj and Francisco and from earlier. And then I'll say a little bit about the transition or kind of some of the AI applications. So I think a couple points were noted that I just wanted to say a little bit more about. And so one is the when using automated scoring in, say, reading assessment, and students write their responses, and you start to see different dialects in the different responses. That's one of those places that can be problematic for automated scoring when those dialects are associated with performance. Even though that's not the performance you're interested in evaluating, these predictive models that are so large can pick up on that signal and bias things. It's even in a formative assessment context, it's something to be aware of. There was the other question about, I agree, like it's amazing what Gemini, ChatGPT, Claude, all these different generative models can do in terms of producing quality assessment items. and certainly on the surface of them. And you know, you might get 100 excellent ones, and then the 101st there's something wrong with. And that's one of the difficulties is how do you identify those few problem ones before they're in front of a student? And how do you make sure that the student never sees that? And that's where this idea of automated evaluation comes into play. But in order for that to work well, it needs to be trained, which means you need a lot of data where human item writers and human experts like Luis have said, yes, all of these AI generated items are great. These aren't. And then you try to find, is there signal in what's a good item and what's not? And so that's one of the difficulties is where we have tons of language on the internet to generate generative models, we don't have that same scale of data for multiple choice items. You know, there's maybe tens of thousands or something you might find in textbooks or assessments, but you're still kind of stuck with fairly, in a predictive modeling sense, that's a small data set. And so a lot of times that's what makes using generated items difficult. And so the last thing I'll say, and then I'll hand it off to Luis, is how we transition to using AI. We spend a lot of time doing research to make sure to minimize the chance of negative consequences for students or for examinees. So whether it was automated scoring or automated item generation, a lot of research was done before we moved those things forward. And I believe the same can be said for even the move to digital-based assessment for NAEP. With that, I'll hand it over to Luis.
Thank you, Matt. And Matt, also, I would like to talk about the difficulty question later, prediction of difficulty, if we can. After I want to mention a couple of things about the transition to digital. I think Professor Ruben and Marilena, you asked about, okay, how do you ensure that the tools or what you use, the interaction, are intuitive and easy to use for the students? And we have followed some rules. I mean, the rule number one is we're not doing this just to keep up with technology. We are trying to incorporate interactions that are natural for the construct that you are assessing. For example, if we want a student to represent a number in a number line, so we create a tool that is a number line that allows a student to put tick marks and place numbers in there because it's a natural interaction. So it actually corresponds to the construct that you want to assess. It's not just for the sake of technology. Number two, we want the tools to be intuitive to use. So for that, you do a lot of play testing, usability studies. We check what is out there. There are some apps or tools that teachers use in the classroom that we want to make sure that is somewhat the interaction is intuitive itself. And we do test it with teachers and students. What we have found is, this is what we call the generational divide. Most of them, at least in the US, what we have been doing, they don't even read the instructions and they already know how to use these tools. It's incredible how easy it is for them to interact with this tool. The teachers are the ones that are panicking and they read the whole thing and they are like, they have to make sure that they read it completely before they even try. The student just tried and very quickly, I mean, again, it might, I don't know, I'm not a cognitive scientist, but it might be due to how they interact with the phone. Whatever reason is, the games or something, that they find it very easy and very intuitive. So again, I think one approach to integrate them carefully and validly is to, again, make sure that the tool is playing a purpose and a construct-related purpose. If you want to have questions about ordering quantities, I can have a tool that allows them to order them instead of giving them a list of orders. And that will be natural for the question that you're asking. It has to be intuitive. You have to do significant amount of pre-testing, play testing, usability studies to make sure that, and we follow what we call the WCAG guideline, the guideline for web information in the computer. So we try to follow all those guidelines to make sure that, you know, a student, from the usability perspective, they find it very easy. It's not become barrier to show what they know and can do when they face the assessment. So yes, Professor Ren, all of those tools that I try to show, they have in research, they are there for a purpose. I show one about a zone, which was like an image, and you had to click on the part of the image that corresponds. In the medical field, when the students are tested about, can you find in an X-ray where there is a problem? It's natural for them to point out to where the place in an X-ray there seems to be an issue. So it's easier to have an item that actually allows them to do that instead of to try to select it from a multiple choice or something like that. So if the interaction is natural for the construct or for the real activity that you're trying to represent in the assessment, the easier it is for the student to interact with it in some sense. So again, it's not just for the sake of keeping with the technology, it's because these interactions really allow us to represent the construct in real life better than the multiple choice, for example. Matt, you want to go to the difficulty?
Yes, sure. Yeah, sorry, I forgot to mention that. Yeah. So in terms of the, so when we have generated items that need to be calibrated, and how do we do that? So there's a couple of approaches. So there are some researchers who advocate for, well, you can have generative AI answer the questions for you, which you can then use to calibrate. And some researchers provide some evidence that say, you can kind of do that. Our research, and at least in the examples we have seen, suggest that doesn't work, that it's too hard. And it goes back to the standard principle. You want to test your assessment items in the population in which they're going to be used. You're not building assessment items to test generative AI. You're using test items to assess children or college students or whatever. And therefore, you really, the standard is you need to test those, pre-test those in that population if possible. So I am a strong advocate against using generative AI for anything other than the most basic pre-testing, just to make sure it's not like, if you're confusing generative AI with your question format, that's bad. So I think it's okay for that very basic review. Did I do something really silly with this item? But beyond that, to use generative AI to respond to a question, I'm not convinced is going to be fruitful. I haven't seen anything that's convinced me otherwise, and my mind suggests that I don't think that'll be something that'll work very well. The other approach is to try to actually take the question. I mean, kind of mathematically, statistically, it's similar to the automated scoring process. I've got text for a question. If it's multiple choice, I have the different answers. Can I take that text and then put that into a predictive model that will then predict its difficulty? And we have a couple researchers who have done a lot of that work with, they've primarily focused on TOEFL and TOEIC, but they also did a study where they tried to do this with NAEP items. Mm-hmm. TOEFL and TOEIC, there is some hope because there are thousands and thousands of example items that have been calibrated in the past. NAEP, there's hundreds that we have access to, because this research project was focused on publicly available items and parameters. There is a little signal there. There is a little bit of signal where the content of the item is predictive of difficulty, but it's not quite at the level that you'd be, okay, I've pre-tested my items now. If you know Bayesian statistics, the most fruitful thing is you might use that to build a prior, so then your pre-testing sample can be smaller.
Correct.
So you can combine maybe information from this predictive model with actual students, with a smaller sample of students responding to those questions, and get the same set of reliability that you might have used only with students. And I should have probably included something in my talk. You know, this I think is the next generation for our field, is combining the AI with the statistics, with the psychometrics in a unified way to solve all of these problems at once. Rather than we do AI over here, then we take the output of that over here, we do psychometrics with it, and then we put it back through AI to do automated feedback. No, we need something integrated. And I think that's going to be kind of the next where we're really going to move things forward.
Você está sem som, Maria Helena.
Aí, bom, primeiro eu quero agradecer demais. Eu simplesmente adorei Luis Saldivia, professor Neto, nossos comentadores, mas eu achei excelente. Foi para mim um grande aprendizado ouvir tudo que vocês estão fazendo em termos de pesquisa, os avanços, as dificuldades, a qualidade do que foi apresentado. Trouxe uma contribuição muito grande para a nossa pesquisa e para todos nós que trabalhamos aqui na área de avaliação, e espero que isso possa também inspirar as avaliações brasileiras, o SAEB, as avaliações estaduais, tudo mais, porque eu acho que tem uma revolução em andamento no campo das avaliações e aparentemente isso ainda não é percebido aqui no Brasil como deveria ser, né, tendo em vista as mudanças todas, do ponto de vista do comportamento das pessoas, da sociedade, da escola, dos jovens, dos aprendizados, das tecnologias, tudo mais. Então, para mim, olha, muito obrigada, obrigada mesmo, agradeço Fundação Itaú, agradeço o ITS, o tempo de vocês, muito importante, espero que a gente tenha oportunidade de trazê-los presencialmente aqui no futuro para fazermos aqui. Eu sei que o Luis Saldivia gosta muito do Brasil, né, Luiz? Então, para que a gente possa, de fato, interagir mais e aprender com todas as pesquisas e avanços que o ITS já tem. Priscila, quer dar uma palavrinha de agradecimento, por favor?
Claro, quero agradecer, né, aos nossos convidados, né, o Luiz, o Matt, pelas apresentações e com certeza vai enriquecer muito o nosso levantamento, a nossa pesquisa aqui e nos dar insights esperançosos e ao mesmo tempo desesperados sobre o que a gente precisa fazer aqui para avançar nas nossas avaliações em larga escala. Muito obrigada.
Então, muito obrigada a todos. Um grande abraço e um beijinho. Tchau, tchau. Beijo para todos. Quer falar, Luiz? O Luiz quer falar. Dá um. Fala.
No, I reiterate that thank you for the invitation. And Matt, thank you for helping me with to have this discussion. Again, I hope that as colleague, we continue to discuss, collaborate. I mean, NAEP is a very open. It's a lot of materials about NAEP outside about our research. We have published a lot of the work that Matt was saying and other work. So if you look at the ETS inside, we have some of the papers there. And if you have any questions, if you have my email, you have Matt emails.
Yeah.
Of course, we're here.
Tá ótimo.
Yeah.
Muito obrigada, hein? Um
Thank you.
abração. Obrigada a todos. Bye, bye. Obrigada,
Bye.
Chico,
Goodbye.
Marinês, Rubem, toda a equipe aí que trabalhou, Lígia, Gabriela, os intérpretes. Muito obrigada, gente. Um abração.